Good evening, sir. Good evening.
Good evening, Namaste, Hare Krishna. How are you?
Good evening.
In the previous class, we discussed about how to simplify irrational numbers, how to multiply, add, and subtract irrational numbers. So let us take some expressions and simplify for practice purpose.
Excuse me, sir.
Simplify. Root 28 plus root 42 divided by root 175 plus root 252. This is the expression and we have to simplify. Do you think you can try this?
So we can rationalize it.
If you think you can try, then I'll wait, else I'll do it. Say yes or no. No idea. Trying. Are you trying? Are you trying? Am I audible? Am I audible to you? Samaira, Ahana, am I audible? Am I audible?
Yes, so you're
Are you trying this? Your voice is not coming.
yes, sir. I'm sorry. I'm out.
I couldn't get. You are trying or not?
Sir, I'm trying.
Okay. Okay, I'm waiting then.
Sir, I'm not able to do it.
Did you finish it?
No.
No. Okay, no worries. I'm going to show you. Tell me what's the doubt.
Sir, like in today's class, in today's maths class, the teacher told about the multiplication of irrational number. So she gave us an example about root 2 multiplied by cube root of 2. The answer was 6.
Just a moment. You said root 2 and
Cube root of 2
cube root of 2.
into
And the answer was Okay, we will discuss about it. Let us first do this question, then we will discuss about it.
Okay, sir.
See, in these numbers, whenever you have this type of expression, you should try to simplify each number. How to? 28. This is the rough work I am showing here. Rough work. It's not necessary to write, but I am showing it because you are a learner now. 28 means 2 times 2 times 7. 42 means 3 2 ja 6, 7 ja 42, right?
Yes.
175 is 5 times 5 times 7. 5 5 ja 25, 7 ja 175. 252 is 6 into 6 into 7. So what we notice here is 28, if it is under a square root, then it is under square root, and this will give us what? 2 root 7,
Yes.
right?
Yes.
If we put 42 under square root, that means we are going to have 3 to the 6 into root 7.
Yes.
I am separating root 7 from each of them. Here also, if we put 175 under square root, 5 is squared here, so 5 will come once. Root 7 is out. 252 under square root means this under square root. Then 7 will, 6 is paired here, so 6 will come out. Does this make sense?
Yes.
So the next step, second step, I am not writing the first step. Question itself is the first step. Root 28 means 2 root 7. Plus 42 is like root 6 into root 7.
Yes.
In the denominator 175, root means 5 root 7. 252 under root means 6 root 7. Now what we see, root 7 is common in the numerator as well as in denominator. We can take it out. 2 plus root 6 remaining in the numerator. Denominator root 7 common. 5 plus 6, that is 11. Now root 7 to 1 ja root 7 got cancelled. We have 2 plus root 6 by 11, and that's it. Simplified.
Sir, can't we rationalize that in the first step only?
You mean you want to rationalize the first step?
Not the second.
This one?
Yes.
But why there is no need to simply rationalize. If you can cancel out root 7, denominator is already.
The question is rationalize them, so we have to rationalize them. Then
What is the meaning of rationalize?
like the root should not be in the denominator.
Rationalize means making rational, right?
Yes.
Making rational. Do you think 11 is rational?
Yes.
I made it rational here. I made it rational this way. So I rationalized the denominator. I cancelled out root 7 from them. Only 11 is remaining in the denominator, so already rational. Denominator is already rational.
Yes.
Then actually our motive is to rationalize the denominator, making the denominator rational. So make it this way or make it that way, your choice. So choose the best way, and this is the best way. Now let's talk about your doubt. Root 2 times cube root 2. See, root 2 means 2 raised to the power 1 by 2, and cube root 2 means 2 raised to the power 1 by 3. Is that right?
Yes.
Because of the law I taught in yesterday's class, a raised to the power m and V shape has letter n, that means a raised to the power m by n. Using that property, I wrote it. Now multiply sign between them. We see their bases are same this presently, so we can add their powers, right? Bases are same and multiply sign between them. So write the base only once and add their powers, exponents. What is this? 2 raised to the power 5 by 6.
5 by
3 2 ja 6 in the denominator. Now cross multiply. 3 1 ja 3, 2 1 ja 2, 3 plus 2 5. Do you think this is equal to 6? No. This is not equal to 6.
Yes.
We can further write it like this. 2 raised to the power 5 raised to the power 1 by 6. Is that right?
Yes.
2 raised to the power 5 means 32. And power 1 by 6 means it is the sixth root. So we can rewrite using root sign like this. Sixth root of 32, which is not equal to 6. So that statement is wrong. This statement is wrong. Sixth root of 64 will be equal to 6, not 32. Why so? Reason very simple. Sixth root of 64. 64 means 2 raised to the power 6. Is that right? That means 2 raised to the power 6 by 6. 6 cancels 6 in one time. So 2 raised to the power 1. Actually not 6. This is equal to 2. So sixth root of 64 will be equal to 2. Sixth root of 32 is radical. Cannot root sign cannot be removed completely. Check it once again. If you think anything not logical, let me know.
Yes. So our teacher taught us that in the B part of the root, it equals to 1, not 2.
What is that? Sorry.
Like 1 root.
1 root 2.
No, like the B part of the root is equals to 1, not 2. You told me that 2 is hidden there. He taught us that 1 is hidden.
No, 2 remains hidden by default. 1 never remains hidden. 1 is having no meaning there. If you think it should be 1, 1 is having no meaning. According to this rule, suppose if this is 1, what is the meaning? You will write 1 here in the denominator. That is having no meaning. Suppose this is a square, or let's take 2 square under this. So it's going to be 2 raised to the power 2 by 1. Making no sense. This is simply 2 square. Because 1 in the denominator making no sense. So 1 never remains here. 1 can never remain here. At least 2 may exist and 2 remains hidden. If we don't write anything, like if we write this, that means this V shape contains 2 hidden here. I hope you understood it.
Yes.
Okay. Next. Simplify. cube root of 5 square times fourth root of 6. Do this. Would you like to try?
Yes, sir.
Okay, try this. I'll wait for 3 minutes. Submit your work in 3 minutes. Whatever it is, complete or incomplete. Are you done? It's more than 3 minutes now. Leave it.
No, sir.
See here. We have cube root of 5 square times fourth root of 6, and the rule is nth root of a raised to the power m can be written as a raised to the power m by n. This power goes to numerator and this number goes to denominator of power. So it is 5 raised to the power 2 by 3, and this is 6 raised to the power 1 by 4. Now we notice here, neither the bases nor the powers are same. Neither the bases are same nor the powers are same. In that case, I taught in the such an example in the previous class. In this case, we have to make the denominators of power same. Denominators of powers same. Let us make it 3 and 4 LCM. LCM of 3 and 4 is 12. So let's make their denominators 12, making equivalent fraction rule. 2 by 3 is equal to 8 by 12, right?
Yes.
And 1 by 4 is equal to what?
3 by 12.
Right. So we can use equivalent fraction method so that their denominators can be both same, and that is 12. First one becomes 5 raised to the power 8 by 12. The second one becomes 6 raised to the power 3 by 12. Now, to make the powers same, we will remove their denominators. Remove denominators from there. How to? 5 raised to the power 8 raised to the power 1 by 12 times 6 raised to the power 3 raised to the power 1 by 12. Now see, their powers are same, right? Their powers are now same. So we can multiply their bases. The rule is this: if you have different bases with the same powers, you can directly multiply their bases together and keep the power same over it. We'll follow that rule. Let us multiply the bases together. Since it's going to be very large number, I'm not going to simplify this. I'll write it instead this way only. And the power is 1 by 12. Done. Now you back write it in the form of root, where V shape will contain the number 12. 12th root of this. Any question?
No, sir.
Now we are going to discuss, learn a new topic, that is representation of irrational numbers on the number line. Representation of irrational numbers on the number line. As you know, irrational numbers can be written like decimals like 2.1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 4, 6, 1, 4, randomly whatever. Non-repeating, non-terminating and non-repeating. So this is the first way to write an irrational number. The second way, in the form of radicals like root 2, root 3, root 6. We cannot remove the root sign from this expression. So these are all irrational numbers. Let us now see how we can represent these numbers on the number line. First, let's talk about decimal representation on the number line. First type, decimal. Actually, there is no perfect method to show that number on the number line. But what we do is just estimation. For the estimation purpose, we draw a number line. Can you guess between which two integers this number lies? First one. Between which two integers?
Sir, I don't know.
2 and 3. It's more than 2.
Yes.
2 and 3 are the integers between which this lies. So we write here 2, here 3. We are sure that this number lies between 2 and 3 on the number line. And we also know it is 2.1. Let us focus over the first digit after decimal. First digit after decimal, that is 1. So if we divide this distance between 2 and 3 in 10 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is 3. I have divided it in 10 equal parts. Can you tell me what is the first point representing?
Sir, 2.0.
2.1. And what is the second point representing? 2.2, right? Similarly, it is 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9. Now can you tell me our number lies between which two decimal numbers here?
Between 2 and 2.1.
2 and 2.1, sure. So you think this first number is lesser than 2.1? This number is lesser than 2.1, yes or no?
It is greater than 2.
Greater, then how it can be on the left side of 2.1? If this is greater than 2.1, then this number should be on the right side of 2.1, isn't it?
Yes.
So between which two numbers this should lie? Say again, please.
2.1 and 2.2.
Exactly. It's more than 2.1, so on the right side of 2.1, but on the left side of 2.2. This is lesser than 2.2. So now what we do is, like magnifying glass. If we magnify the distance between 2.1 and 2.2, just magnify it and then divide it in 10 parts again. How to magnify? For visualization purpose, what I will do is, I will draw another number line and I will visualize 2.1 here. And 2.2 somewhere else, like here. And just as the previous step, here also we will divide it in 10 equal parts. So this is my plan. I am going to divide it in 10 equal parts, then I will take the next number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This number is 2.2. Now, what is the first point representing here after 2.1? 2.11. It's already 2.1. And since it is first point, this is already 2.1, and since it is first point, so it will be 2.11. Second point will be 2.12. Third is 2.13. Then it is 2.14. It is 2.15. This is 2.16, 2.17, 2.18, 2.19, and then 2.2. Well, now tell me on this one, between which two decimal numbers our number lie?
2.1 and 2.12.
2 point what?
And 2.1 and 2.12.
You mean 2.11 and 2.12, right?
No, 2.1 and 2.1.
Okay, you are saying 2.1 and 2.11, right?
No, 1, 2.
I'm not getting your point then. If I take here 2, then you are taking a gap of 2 segments. Between which two decimal numbers this lies?
2.11 and 2.12.
Okay, you said 2.11 and 2.12. So you think this number is greater than 2.11, right?
Yes, sir.
And this is smaller than 2.12, right? Check it. Is it lesser than 2.12?
It's equal.
This number is lesser than 2.12?
Yes, sir.
No,
It's
check
lesser
it.
than-
It's not lesser, it's greater, not lesser. It's 2.123. It is 2.12 only. It is 2.120 and it is 2.123. It's more than 2.12.
So we will take the greatest number.
Got it?
Yes, sir.
This is greater than 2.12. That means it should be on the right side of 2.12, not on the left side.
Yes.
Greater number always lie on the right side. So it's more than 2.12, but it is lesser than 2.13, right?
Yes, sir.
This is lesser than 2.13 because the second digit is 2 and second digit is here 3.
Yes, sir.
That means this lies between 2.12 and 2.13. Did you understand this?
Yes, sir.
That means you are getting confused by in the comparison of decimal numbers. Be much more careful. Comparing decimal numbers is a very basic idea. If you get confused in that, it may be a big problem. Okay, so now we know this number lies between 2.12 and 2.13. So to visualize it, again we draw a number, means this is endless process because there are endless numbers, endless digits. So this process will be endless. We will never stop. But since we are not ready to invest that much amount of time, so by visualizing 2 or 3 number lines, we stop and we say, yes, this is the method, this is how we can show. Means our motto is not to show the number on the number line because we know it's endless process. So we are not going to show it. We are not going to waste our time. It's not invest, it's waste. We are mathematicians, so we have to just show to someone that we know it. We know the process, but we are not ready to show all the things. That's why I am showing it only on 3 or 4 number lines. So maximum 3 is okay. I am drawing I'm taking one more line after this. Can you tell me which number I should take here?
Sir, 2.12 and 2.13.
Right. So for visualization purpose, I'll draw a line like this. I'm indicating that I'm magnifying the distance between this short distance. I'm magnifying this short distance. So this is here 2.12, and then I will take again 10 parts, and the 10th one, the last one, will be 2.13. Before that, I'll make the parts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 10th one is going to be 2.13. What is the first point representing here?
2.123. 2.121.
Correct. 2.121. 2.121. Then it is 2.123. But we don't have that much space, so I'm not going to write all the things. I will just write those two numbers between which this still lies. Can you tell me? Which two numbers between which this number lies? I will highlight only those two.
2.123 and 2.123.
2.123 and
2.124.
that's right. 2.123. So 123, this one. 2.123 is here, and the next one is 2.124. Exactly. This number lies between these two. But we stop here because we know this is endless process. How many number lines will do? I'm not going to do it. Our motto is to show our knowledge, not to do hard work. We are not intended to do the hard work. We are intended to show our skill, and we have shown our skill. We know this is the method, so we will not finish it. This is endless. Done. First type of irrational numbers can be visualized on the number line this way, by magnifying method. This is known as magnification method. Is that okay?
Yes.
Can I ask a similar question to you?
Yes.
No?
Yes, sir. Yes, sir. But a children in the class asked this question, and a teacher said this type of question will not come in our exam.
I know. This was removed last year due to pandemic. It is not out of syllabus, let me tell you. This is not out of syllabus. This was temporarily removed because of pandemic situation. So you should know it. Would you like to try?
Yes.
Okay, at least you will be agreed with one thing. At least you should know how to compare decimal numbers, right?
Yes. Yes.
And I have noticed you were getting confused in the comparing decimal numbers. So at least one question you should try.
Okay, sir.
Visualize 0.25683105338 and so on the number line. Try this and submit within 3 minutes. Submit your work in 3 minutes. submit now? It's more than 3 minutes. Did you submit?
Yes, sir. But I have not completed it. Let's put on this here.
Whose work is this? Amira. Okay, see here now. The first number line. This number is more than 0.2, right? More than 0.2, lesser than 0.3. So I'll take 0.2 here.
Sir, I have also.
Okay, very late. You have drawn just the first step here. Just the first step. You have taken 0.2 and 0.3, that's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now it is 0.25. More than 0.25, lesser than 0.26. This and this. Again correct. Now in the third one, 0.256. This time you have highlighted 0.255. No, it should be between 256 and 0.257. Between 0.256, this number, and this number. Got it?
Yes, sir.
0.2 and then 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This is 0.3. I don't have much space, so I am not going to write each of them. I'll write just those numbers where this may lie. 0.25 and 0.26. 1, 2, 3, 4, 5. This 0.25 and this 0.26. I will highlight the portion between them. First number comes here, 0.25 and then 0.26 here. I'll take 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 0.26. Now again, I will not write each of them. I will write only the required two numbers which are required. Third digit, two digit already taken, 2 5. I will consider third digit now. After 5, third digit is 6. So 1 2 3 4 5 6. This one 0.256, and this one 0.257. So between these two, our number lies 0.256. This number is more than this, but lesser than this. Check it. So I notice, Samaira, you have a bigger problem handling decimals, right? That's why I gave this question to you. This is why you need to practice over it. Visualization is not a point. Our motto is not to do this visualization method. Our motto is to understand how to compare decimal numbers. And after 2 steps, Ahana also got confused here, or maybe it was hurriedly doing, right, Ahana?
Yes.
Because at the last moment I said it's time over, submit quickly, so hurriedly you did this. However, this method may or may not be in our syllabus, but comparison of decimal numbers is of course in our syllabus, because this thing is not of class 9th level, this is of class 6 7 level. We must understand that decimal is taught in class 7 first time, and if we are not aware of, if we are not friendly comparing decimal numbers, that means we have not practiced the class 7 content. Well, I stop it here. I hope you understood it. Okay. Now let's come to the second one. Second number. When we have radicals, how to represent this on the number line? This thing. Root 2, root 3, root 5, etc. on the number line. To do this, we need a very small piece of knowledge that you already have, but just to make you aware, I am going to show you. You know what is Pythagoras Theorem?
Yes.
You know what is right triangle.
Yes.
You also know how to use Pythagoras Theorem inside a right triangle.
Yes.
Let us see a specific situation. When you have a right triangle with base 1 unit, height also 1 unit, and see how long is the hypotenuse. Can you tell me how long is the hypotenuse?
2.
Do the calculation and check it. A brief calculation, not to show. Root 2, that's right. Root 2. Now think of another right triangle where height is still 1 unit, but the base is root 2 unit. Now guess how long is the hypotenuse?
So will be like minus root 2 minus 1.
No, check it. If you are unable to guess, do the calculation.
Root.
Root 3 is right. Is it okay, Ahana?
Yes.
Now consider one more right triangle. This time, height is still 1 unit, but the base I am taking root 3 unit. Guess what is hypotenuse?
Root 4.
Sure,
No, 2.
that is same. Root 4 or 2 are the same things, right?
Sir, root 4. Sir, root
Yes,
2.
yes, root 4 and 2 are the same things, right?
Yes, yes.
Okay, so let's call it 2.
Okay.
Well, what is pattern? Pattern is that we are keeping the height always same, but the base
Will change.
is having a pattern. Root 1, root 2, root 3, and so on. We will be keeping height, or you can say perpendicular, always same, 1 unit.
1.
First time perpendicular 1 unit, base 1 unit, and hypotenuse root 2 unit. But if we take perpendicular 1 unit, base root 2 unit, then the height becomes root 3 units. If we take perpendicular 1 unit, base root 3 units, then the height becomes 2, that is root 4 or 2, whatever you say. Now we again continue further. 1 unit perpendicular, base 2 units this time. Notice what I am doing. Root 2, root 3, 2. The previous step, hypotenuse, becomes base in the next step.
Yes.
Previous step, hypotenuse, becomes base in the next step. Now guess what is the hypotenuse in this step?
Root 5.
Root 5, right? Again, if we continue 1 unit perpendicular, root 5 unit base, then the hypotenuse?
Root 6.
Root 6, exactly. So this is the pattern. Now the question is how to use this pattern, because our motto is to show these numbers on the number line. So now let's draw a number line. I'm going to show root 2 on the number line.
Sir, ये
Sorry.
Okay.
See, I'm taking 0 here and 1 here. What does that mean? That means this is 1 unit length. So now I will draw a perpendicular here at 1 of length 1 unit. This is 1 unit, base is 1 unit, perpendicular is 1 unit. I will join to create hypotenuse, and I understand.
In centimeter or inches both.
Sorry, yeah, it may be anything. I have not mentioned any particular unit. It may be millimeter, centimeter, decameter, meter, hectometer, kilometer, whatever. I am telling unit. That unit may be anything. Okay. So if I have 1 unit base, 1 unit perpendicular, then the hypotenuse is going to be root 2 units. I understand this fact because of Pythagoras theorem. Now what I will do is I will take my compass I will measure this distance with the help of compass. Check it. Is that right?
Yes.
Root 2 units. My compass stretch is root 2 units from 0 to this, root 2 units. Now what I will do, I will draw an arc. What do you think this length should be?
Root 2.
Exactly. I got that number root 2 on the number line. I found root 2 on the number line. This point is representing root 2 on the number line. Now I need to show root 3 on the number line, and I know if I take base root 2, height 1. So here is the base. Now I will consider this length as base because this is root 2 and I need root 2 unit base. So I will consider this unit as base and I am going to draw perpendicular, another perpendicular here of the same height 1 unit. Here it is. Now tell me, if I join 0 to that point here, what will be the length of hypotenuse? Root 3, right?
Yes.
So now I will take the compass again, put the pointer over 0, and another pencil point at this location. Check if it is perfectly put there. Correct? I am going to draw an arc. This is cutting the line here. Can you tell me how much is this length?
Root 3.
Exactly, I got root 3. Did you understand the technique?
Yes. Yes. So can we draw root 3 on top of root 2?
Root 3 on the...
Like you have drawn like root 3 on the left side, can we draw it on the right side? Like on top of root 2.
Top of root 2. I'm not getting your point.
Yes, like make it a spiral.
Yeah, spiral. You are talking about spiral. Yes, we can draw it. That is another thing. Presently, we are showing it on the number line. Line. That is a spiral you are talking about. Right? I am talking about line. I will show you a spiral later. So, did you understand the technique how to show them on the number line?
Yes. Yes.
Okay.
Sir, if we draw it in a spiral or like this, both like measure the same thing.
No, not same. Of course not. Line and spiral, how can they be same? If someone tells line and circle are same, do you think, will you believe it? I will not believe, and I guess you will also not believe. Line and circle can't be same. This is number line. But if you want to show the spiral, you can create it. To create, you will use the same fact First of all, draw a right triangle, 1 unit base, 1 unit height at 90 degree. Join it. You got root 2,
Yes.
this length root 2. Now at this hypotenuse, draw another line here making 90 degree of 1 unit. Now join this. You got root 3.
Yes.
Now at root 3 length line, draw another line making 90 degree of 1 unit again. Every time this length will be 1 unit. And you are joining it now. You are getting root 4, that is 2 units. And so on, you will increase. It will be a spiral.
Yes, sir.
Like this. Never ending process.
Yes, sir.
Never ending, never intersecting. Well, so now if I tell you to show root 5 on the number line, can you do it? Give me the idea. How will you do it?
But so when the teacher showed us how to draw like root 3 and that stuff, she showed us on the spiral way.
And the question was about line.
Yes.
Answer was a
Like
spiral.
show root 2 on the number.
Number line, and she drew a spiral,
Yes.
and you believed it. You believed it. That is amazing. So now I have got the clue. Sometimes I will say line and circle are same, and you will believe it, right? See, if someone is showing the spiral way, does this give the idea how far root 2 is from 0? On the number line, this gives the idea how far root 2 is from the 0. This gives the idea.
Yes, but she also draws like 0 and then make a arch. Like you do.
Yes, you can, but for that you have to draw a line. No? If you are satisfied with the spiral, that is
No,
not
she
good.
draws a line.
Yes, that's good then. If you draw a line like this, and then you every time measure the length with the help of compass, and you cut here on the line, then it's okay. Then the answer is complete. But if the question is show root 2 or let's say root 3 on the number line. Suppose this is the question and answer is this without line. Do you think this is logical?
No.
No. So whenever someone tells you something, use your own logic. Do your own analysis over it. Don't just accept anything without logic. I remember there was a short story in a village environment. A person was completely blind, 100% blind. Eyes were not working. Many people in India call such a person like Surdas. So that person was a Surdas. And he was invited for dinner at some place by someone. There were many others at that place for that dinner. That Surdas also went there. So after serving dal, the liquid dal, the next turn was for ghee. So a person was carrying ghee into a small bowl, the container, and with the help of a small spoon, he was giving 1 spoon of ghee to everyone. He just got some trick, he got some, fun idea. He didn't serve ghee to that Surdas, but told him, I have served you the ghee. Since Surdas was not able to see, so he was puzzled. He just believed, maybe he has given me the ghee. He is serving ghee to everyone. I am also in the row. So he must be, he was not able to see if the person has given the ghee. He just believed it. He believed the God, so he believed it. The person who was serving the ghee moved away. Some person sitting nearby told Surdas, oh bhai, he has not given you any ghee. He just cheated you. Then Surdas thought, oh my God, I got cheated. He called that person back. Oh bhai sahab, ghee wale, please come here. Then he applied some logic. You know what he said? He was actually puzzled how to tell him that you cheated me. He may be angry with me. How can I say you cheated? So he said, भाई साहब आपने घी तो डाला, गरगराहट की आवाज नहीं आ रही थी, एक बार फिर से डालो. So always use your brain. Someone tells you something and you believed it. Ask that question. A spiral is not a line. Question was about line, answer is about spiral. How this answer is satisfying that question? Of course not satisfying. So those two situations are different. Okay, whatever. Give me a moment. I'm checking what else we have to discuss. It's almost done. Only one thing remaining that we'll do in the next class. We had to discuss how to represent irrational numbers on the number line. There were two types of irrational numbers considered, one in decimal form, second in radical form, root sign. And we have discussed about both. Now the only one thing remaining, that is, if any decimal number comes like root 9.3 under square root, how to show this on the number line? This type of question is remaining. Only one item in this chapter that will finish in the next class, and this chapter will be over, finished. So I suggest, except this item that we have not done, practice all the rest of all the items from your textbook, whatever you are following. Okay? And make sure that you practice all the questions without skipping anyone. And if you have any doubt, any question, ask it in the next class or next to next by latest. Now time has happened to end the class. Bye bye. See you in the next class.
Bye. Bye.